So here we're going to look at how we can find the equation of the linear line that passes through 2 points. So for example, it could be the points 2, 5 and the point 5, 11. Okay, and we want to find the equation of the linear line that goes through these 2 points. So if we have a look on a Cartesian plane, what this looks like, and we'll just have that first quadrant there. Then 2, 5, then that's going to be, say, about here, and 5, 11 will be around about up here somewhere maybe. Then the only possible linear line that can go through both of those points is this one, like that. There's no other linear line which will go through both of those 2 points. So we need to find the equation of this linear line. So what is the equation of this? Well, the way that we tackle that, we know that the equation of any linear line has to be y equals mx plus c. So the equation of that line has to have that format. So now we just need to find what m is, or our gradient, and we need to find what c is, our y-intercept. So if we start off with the gradient, remember, so the m value, which is my gradient, this is equal to the rise over the run. Okay, the rise being how much I change in my y-axis, so up and down, and my run being how much I change in my x-axis, my distance left and right. Okay, and those little triangles, they're the Greek symbol delta, which just means a change in. Okay. Now, if I want to work out how much I've changed in y, well, let's see how much have I changed going from 5 to 11. Okay, so what's happened there? Well, I've gone up 6 units. Okay, and you can see going from this point here to this point here, I've climbed upwards 6 units. So I've gone positive 6 in my y-axis. How far have I come in my x-axis? Well, I've gone from 2 to 5. So I've gone positive 3. Okay, so I've got a positive distance along my x-axis, which we see coming along here. Okay, so my gradient would have to be 6 divided by 3, which is 2. So I now know that the equation of this linear line is y equals 2x plus c. The only bit that I've got to find now is my y-intercept, and I'm going to do that by substituting one of these 2 points into this equation. Now we're going to put both in, and I'm going to show you that it doesn't matter which point you choose. So we'll just take a note. We've got the point 2, 5 and the point 5, 11. So let's come down here now. Let's have a look at our equation and the 2 points that we've got available to us. Let's start by putting in the point 2, 5. So in for y, I put a 5. And in for x, I put a 2. And I can solve for c. So 5 equals 4 plus c. So c would have to be 1. Let's see if I get the same answer by putting in this point. So I put in an 11 for my y. And I put in a 5 for my x. And I can solve this equation. 11 is equal to 10 plus c, so c would have to be 1. So I get the same answer, doesn't matter which point I choose to put in. So the equation of my linear line that goes through those 2 points would be y equals 2x plus 1. Okay, so the equation of this linear line here is y equals 2x plus 1. We'll do another example. Let's look at finding the equation of the linear line that passes through the 2 points, -3, 1, and the point 1, -11. So let's see what's going on here. So if we have a look at our Cartesian plane, so we'll draw that in now. So here we have a Cartesian plane, and let's see where these points roughly sit. So at about -3, 1, so we've got a point about there somewhere, and we've got a point at +1, -11, so all the way down here. So the only linear line that includes those 2 points is going to be this linear line here. Okay, and I want to try and work out what the equation of that line is. So we know that the general form for any linear line has to be y equals mx plus c. But the thing that distinguishes different linear lines is the gradients and the y-intercept. So we've got to find out what they're going to be. So let's start with the gradient. This is our m value. Remember, the gradient is my rise over my run, or my change in the y divided by the change in my x, so my rise over run there. So how much have I changed in my y? Well, I've gone from 1 to negative 11 here. Okay, so I've gone down 12 units in my y-axis. So you can see that happening going from here all the way down to here. We've gone down in y-axis value. But what have we done in the x-axis? Well, I've gone from negative 3 to positive 1. So I've climbed up 4 units along the x-axis. Okay, so we've come along here on the x-axis 4 units. So my gradient, negative 12 divided by positive 4 gives me negative 3. So that's the gradient of this linear line. So I know that my new equation looks like y equals negative 3x plus c. And now I've just got to find the y-intercept. So I can put either of these points in. Again, we'll do both, and I'll show you that both of them work. But you only need to do one. Let's start with negative 3, 1. So if I put that point in, I've got a 1 for y, and I've got a negative 3 going in for x. And I can solve this equation now for c. So 9 plus c, so c would have to be minus 8. And I can do the same for the point 1, negative 11. I can put a negative 11 in for y, and I put my 1 in for my x, and I solve this equation. So negative 11 is equal to negative 3 plus c, so c would have to be negative 8. So I know that when I put my c back into here, that the equation of this line is y equals negative 3x minus 8. So that's how we can find the equation of the linear line that goes through 2 points.